you just tell different sets of data to sort from a certain way, like from lowest to highest or highest to lowest or whatever?
Yeah, there is. So if you go to up at the top of the home tab, there's a sort and filters, and you can just do like from top to bottom. You know what I mean?
Okay.
Yeah.
Shut up, cat. Okay.
Right.
Very nice.
Okay, let's all right, okay, so number 1, or number 3, I guess, in part 2. So what is the research question? All right, so
I put is the mean age at death different between the 3 types of writers?
yeah, okay, perfect. And then the null is that they're the same, and the alternative is that they're different, or like the mean is.
Yeah. The only thing I'd change with that is like the alternative is like just at least one of them is different. They don't all have to be different.
Just a one.
So if you had like if you had 6 sets of data and 5 of them were the same, but one of them was different, then you would reject the null hypothesis. So I wasn't sure what to put on the collect the data thing. And
Yeah,
so I kind of referenced the answer sheet, and basically it's just we don't know how it was collected. We just know that they looked at the ages of death for female writers in North America. Like, kind of an interesting question, I guess.
yeah, I thought that was weird. It's like I was like, I don't know, I don't know, a spreadsheet.
I got downloaded this thing from the internet.
Yeah, from the internet. And then, so for this next one, so I just said for like, wait, for the novelist, I have a mean of 71.448, standard deviation of 13.052, and there's 67 novelists. Poems, there was a mean of 63.188, standard deviation of 17.297, with 32 in the sample size. With nonfiction, 76.875, standard deviation of 14.097, and 24 is the sample size is what I got.
Yeah. And then just have the oh shoot, what do they call them? I forget. Box plots.
Yeah.
Nothing really to say about those. So number 4, to make inferences, what type of hypothesis test is appropriate? I said the ANOVA or the ANOVA.
Yeah.
For several means. Then what are the requirements for this test? I said each group is normally distributed. each set of data or each group or each set of data.
Sorry, I was having a coughing fit. I didn't hear you.
For B, I just said each group or set of data is normally distributed.
Okay, yeah. All right, then we have all of our QQ plots or QQ graphs.
Yeah.
So, oh yeah, the variance. Oh, geez, Louise, holy crap. Okay, the variance between the groups. So the variances were like, so the novels were one. It was 170.342. Poems was 299.99 or 9190. Holy crap.
Yeah.
And
yeah.
nonfiction 198.723.
Yeah. So, based on that data and the QQ plots, and the QQ plots show it's not perfectly normal, but variances, it's the lowest variance is not 4 times higher than the highest variance is not 4 times higher than the lowest variance. So we assume it's equal.
Yeah.
Or it's normal. We assume it's normal.
Yeah. Yeah. So
All right, for this test. Yeah.
Yeah. Sorry.
For the test statistic, I got 6.536.
Yeah, me too. And then degrees of
and then degrees of
You can go. You're good.
Go ahead, man.
So
yeah.
So I didn't get the same answer as the answer key when I did it. But it's
I know why.
Why is that?
I know why.
Okay.
Because he put a comma in there, which makes it look like a single number, but it's supposed to be 2 and 120.
Oh, okay, cool. Yeah, because I was like, I don't know what it means, because I was like, I got 2 and then 120, but yeah, that makes sense. Okay.
Yeah. So like I had the same problem. I'm like, I got 2, 120, and 122 on my
spreadsheet.
Excel, and I'm just like, I don't get a 2,120.
Yeah, exactly.
But yeah, no, it's supposed to be stated as 2 and 120.
Okay, cool. All right. So for the p value, I got 0.0019, so 0.002, and that's smaller than the significance level, so we reject the null hypothesis.
Yep. So in my English statement, I said there is sufficient evidence showing that at least one of the ages of death of writers differs from the others.
Perfect. And then 8, or 5, I guess. With further study, we find the poets died earlier than novelists and nonfiction writers. What significance can you conclude from this? So, oh man. I just, I don't like the significance. I mean, I don't know. Maybe it's, I don't know. Like, I can.
See, I didn't find it any quote unquote significance. I was like, I think other factors need to be taken into account. Just the fact that what type of writing they do.
Yeah.
And I said perhaps poets live a more carefree lifestyle than the typical novelist or nonfiction writer, but that could lead to the earlier age of death. But based on the data we have, we just don't have enough to make any sort of significant statement on why.
No, because like I don't know what would be the. I mean, like it's clearly it's eight years lower than the closest in novels, but I think it's probably easier to get published as a published poems than a novel or a full-on book. So I think that's probably what there's more, or like younger poem people, but I don't know.
Yeah,
it really matters.
Maybe they commit suicide more or something. I don't know.
Yeah, they're younger. And
Edgar Allan Poe was both a novelist and a poet, but mostly a poet, and he attempted suicide multiple times. So I don't know. But hey, we got that done, so we can get started on the quiz.
Yeah. Alrighty. Well, we can get this quiz going.
Maybe. Oh, there we go. Holy cow. 18 questions.
So number 3, we reject here when there is sufficient evidence that indicates at least one mean is different from the others. True. Right?
Yeah, true.
Well,
what requirements need to be checked when performing an ANOVA hypothesis test?
Yeah, you're right. I'm sorry.
Data in each group are normally distributed. I think there's only one. Unless the variance is that be equal.
Sample means must be positive. Let me see here. Sorry, let me open up my book.
Yeah, I'm looking at the book right now too. Okay. So requirements for ANOVA, the data are normally distributed and the variances are equal. So
they can be negative?
Yeah.
Cool.
To check if each group is normally distributed, do the following. Construct a QQ plot for each group.
Yeah, that's what I put.
We assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance.
Yep. Okay. So a ANOVA hypothesis test is equivalent to conducting independent two sample t tests between every pair of samples. If there is a 3 sample, there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
4 samples, so you have 1, 2, 1, 3, 1, 4. Then you have 2, 3, and 2, 4. Then you have 3 and 4. So what, 7?
I'm not gonna lie, bro. I'm not entirely sure on this one. I like counting what you're saying, but I'm trying to see.
I'm just gonna type it out on an Excel document. So it's 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 5, 6. So that's 6.
6.
So you have 1, 2, 1, 3, and 1, 4. Then you have 2, 3, and 2, 4. Then you have 3, 4. Those would be the only ones. Yeah. So I think 6. but we'll find out.
Okay. Get rid of these woman poets.
You're gonna open? Try to open the soccer shoes. Oh, there we are. Enable that view, please. All right, so we have A, B, C, D, and E in socks. A, B, C, D, E in socks. 6.
All right. A, B, C, D, E, and socks.
So yeah. Excuse me. C.
Okay. All my information.
Almost there. Okay. Alrighty. So just to make sure I have the right amount of numbers. For A, there was n of 20. B, n of 23, and then the rest are 20.
I got all 20. Let me see here. I might have messed up, but I got 20 for all of them.
Okay, let me just double check here. We do B again. There we are. So that would be 2. B. Okay, yeah, I got 20.
Okay, cool.
Okay, just to verify, I guess, what the means that my numbers are correct. Got 33.1 for variable 1, 32.7 for 29.45, 32, 32.2, and 35.250.
Yep.
Okay, cool. All right, let's move on then in the quiz. What's the minimum smallest variance for the 6 groups?
C 27.208.
Okay, I got that too. What is the maximum?
It's D at 30 or 53.58.
3.158, yeah. 53.158.
Yep. Test for the variance.
Okay, and then
so I said yes because it's not, the smallest one's not 4 times, or the big one's not 4 times bigger than the smaller one.
yeah. Construct a QQ plot for each 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Let's see.
Open up my just instead of my inference one. That'll give me. I can build them on.
Control C. And Control V. Delete. Okay, for A, I got my QQ plot shows that it's normal. If you want to do, okay, so I'll do A, B, and C. If you want to do D, E, and SOX.
Yeah, dude. Whoa. So, oh dang it! I should have these in ascending order. Doesn't matter.
Yeah, it needs to be in ascending order. It needs to be from smallest to highest.
Okay, yeah. I was like, holy crap! But like,
yeah, because it was probably all over the place. Yeah.
Yeah, I was like, what? There's no way that's right. And that was right. That wasn't.
Yeah. So B looks pretty normal. And let's see.
So D is normal. I just changed this to ascending order. Why are you not in ascending order anymore?
Yeah, it resets every time for me as well.
That's super annoying.
And then C is normal as well. So those three are normal.
Perfect. Let's see. Oh, dang it. And then, well, the SOX has like a little bit of an outlier. Actually, these are all. Here, I'll just share my screen. This is the only one that, I mean, it looks normal, it's just a little bit off. So, like, I don't know if it's showing where my mouse is, but you see, like, where the first one is like, first two are on, then, like, there's four that are pretty far.
Yeah.
But for the most part, right?
Yeah, for the most part, it's normal, and B was similar to that, but not that bad. But that's not even that bad, I don't think. I think it's
it's still good, right?
Mostly normal. Yeah.
Okay, cool.
Because even some of the QQ plots for our answer assignment had even worse outliers than that.
Okay.
So yeah, I think it's
approximately normal.
Each of these samples are approximate. Yeah, so true.
Yeah.
Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform text again. What is the p-value when you remove the SOX data?
Holy cow, it goes up to like 0.309.
Yeah. A test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic? Like in the...
Oh, on the applet. Should we leave this SOX deleted for the rest of these?
I'm not sure. It doesn't say to put them back in.
Yeah.
Well, yes. This is the last question for this group. Then we have a different data set for the next questions.
Here, let me go to my book. So F statistic.
Is there an applet for it?
So the F statistic is the p-value is the right of it.
P-value is to the right of the F statistic.
Yeah, p-value for the ANOVA in this area, is the right tail. We will never divide the area in the tail. What? All right, well, I guess maybe you'll throw this stuff in the applet and find out. Let's see.
Yeah, so for ANOVA testing, use F, which is right skew. The p-value of an ANOVA test is always the area to the right of the F statistic.
Does it say always?
Yeah.
Okay, yeah, because I read that it said that it was like the right, but I didn't know if it was. I don't see always in there, but I might be looking at a different spot.
Yeah, I'm at the summary at the bottom of the book.
Okay, cool. So rates too easy.
All right, so we got some more data.
Hot dog nutrition.
I only have 3 this time.
Beef.
Oh, we do tests for calories and sodium. So do 1 test for calories and 1 for sodium.
Beef meat. Poultry. Okay, so do we do like calories and like 1, 2, 3, and then 4, 5, and 6 of sodium, or do we just do them completely separate?
I think we should do them separate, but we have to look at the question.
Okay. Oh, jeez.
Oh, so we're examining the calories and sodium separately.
Okay, cool.
So we're doing calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances. Assumptions to use ANOVA have been met. Okay. QQ plots.
So I got beef.
I'll do poultry.
Oh.
The QQ plot for poultry is pretty normal.
And this is for calories,
little,
right? Not sodium.
Yeah, just calories. There's a little bump out, but nothing big or massive.
For beef, it's normal.
Okay. So I'll do meat.
Which sounds so shady.
I know, right? There's some meat. It's pretty normal too. It's about actually the same as poultry.
Cool.
Just about. So now you have to look at the variances. So we have the lowest variance of 508.566 and the highest of 636.846.
Give me
Is that what you have?
quick minute.
Okay.
I just went straight to the QQ. I didn't plug anything on the inferences.
Oh, okay.
Oh. Did you get? There's more beef than the other ones. Did you get 20?
Yeah, I got 20, 17, 17. So 20 for beef and then 17 for the O2.
Okay, cool. Yeah. All right. So, sorry. So on question 14, what did we examine calories for
So
you?
we had to check. Yeah, we had to check the QQ plots, which they look pretty normal, and then we had to check the variances or compare variances. And so the variances I have are the poultry is 508.566 is the lowest, and the quote meat is 636.846.
Cool.
So the variance is not 4 times. The highest, not 4 times, is the lowest.
Yeah.
So I think with the assumptions, I think we could say they have been met.
Yeah.
The first answer.
All right. Run a ANOVA test to determine if mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, and F equals 16, and P equals 0. My P's pretty high. Oh no, it's really small. I lied.
Yeah, it's really, really small.
Yeah. Sorry, I just had the 3.8. That's not right. What can you conclude? So
should we have sufficient evidence to claim that all 3 hot dog types have different mean numbers? We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories. I think it's the bottom one.
Okay.
Because I don't think we could say that we have sufficient evidence that they're all different. Yeah, but we could say that at least one.
Yeah, because poultry is super low, and then beef and meat are pretty much pretty close. So, all right, sodium levels.
Yeah. Okay. So now at the sodium levels. Okay. Cool. Hot dog. Sodium for beef. Let's see. But did I miss one?
Let's see here.
Oh, I did. Let's see. There we go.
All right. I'm just gonna do some QQ plots.
Okay. I'm putting stuff in the ANOVA test thing right now.
Oh man, I swear I put that as. There we go.
Yeah, so it's looking pretty normal for poultry.
Looks normal for beef. And I got.
You got the meat?
Yeah. Okay, that's cool. Let's copy that. We don't have to copy that. That's right. Yeah, and the meat is normal as well.
Okay, and so we have a low variance with the poultry of 7,180, so 7,180.75, and then the high is 10,492.871. So that is not 4 times higher than the lowest.
Yep.
Or
Been
4
met.
times the lowest. So they have been met. Yeah.
Cool.
Okay, so question 17. Poultry, was it really that bad? Looking at it. I mean, it's not perfect, but it's not terrible.
Poultry. Alright, that's going to be annoying. I mean, it's like the poultry one, like, it's not exactly on, but I don't think it looks that bad.
Yeah, that's what I'm saying. I mean, I think we could live with maybe getting that one wrong and then coming back.
Yeah.
Because I think it's we can assume that it's relatively normal
Yeah.
with the other ones.
All right, so the p-value.
So
Difference.
that was 0.179.
Yep. All right. Conclusion: you can draw by the sodium level.
So it's above the significance level, so we don't have sufficient evidence.
I'll see. But it says that all 3 hot dogs have the same. Was that the mean, or was that the thing that they were all the same?
Yeah, that's the null hypothesis, is that they are all the same.
Okay, we don't have sufficient evidence to reject it. Okay.
Yeah.
Do you want me to submit it?
I can submit it.
Okay.
Okay. 100%. All right. It's been a while since we have 100% on the first try.
How first time go?
Yeah.
Cool beans, dude. Well,
Awesome.
see you tomorrow morning for the exam.
With 15, yeah.
All right, cool.
Sounds
Man.
good to me. I'll probably need that kind of review. This section has been in the first.
I did too, and I thought this last test, I was like, oh, dude, this class is so easy. And then I realized, like, I was doing like a pump and dump. Oh man, I got to do this tomorrow morning, so I'd like to learn it, do it, and then drop it.
Yeah.
So,
Yeah. All right, man. Sounds good. Well, hey, dude, have a good one. We'll see you tomorrow morning.
And bye.
Bye.